All right, I want to show you an example here of Gaussian elimination to solve a system of equations. Um, we'll also do Gauss-Jordan at the end. So first thing I'm going to do is I'm going to take this system of equations and create the augmented matrix associated with it. So 1, 1, 1, 4 would be the first row, and then 3, -1, 2, 3 is the next row, and then 4, 5, 1, 15 is the last row. Okay, so that's the augmented matrix for this system. Now, what I'm trying to do is to create a sequence of matrices. They're not equal to each other. They're by doing row operations to change one into the other. Essentially, we'll be looking at a system and changing the system into a new system that has the same solutions but's easier to solve. Okay, so we're looking to get this to row echelon form. So the first thing I focus on is this upper right corner. This would be the upper left corner. I want a 1 in that spot. Well, there already is a 1. So good, I'm going to move on to the next step. If there wasn't a 1 there, I could do some things, maybe move some, swap some rows around to get a 1 there. I might say, oh, if this was a 7, I might just divide that first row by 7 to make it a 1. I can do any elementary row operations to get a 1 right there. Okay. Now, so I already got 1 there. Next thing I want to do is I want to get zeros below that 1. And we get zeros by using the add a multiple of one row to another, that row operation. So I'm not putting an equal sign here, I'm putting an arrow saying this is being turned into that. And what I'm going to do is I'm going to replace row 2 by row 2 minus 3 times row 1. Okay, so let's go here. My first row I'm going to leave alone, 1, 1, 1, 4. And then I'm going to do this thing. So we've got 3 minus 3, -1 minus 3. Two minus 3. 3 minus 12. 3 minus 12 is -9. Now in this row, we want to create a 0 right here. I'm going to do it in a similar fashion. The 1 makes it really easy to just get rid of that thing. So I'm going to do row 3 minus 4 times row 1. Right? So everything in row 3 minus 4 times what's up there. So 4 minus 4, 5 minus 4, 1 minus 4, and 15 minus 12, right? I'm multiplying this by -4 and then adding it onto here. So 15 minus 16 is -1. 15 minus 16, 15 minus 16, yes. Okay, so there's my next one. This is a completely different matrix than this one was. It's a different system, but we can make the argument that it has the same solution set as that one. In fact, I don't think we've made that argument yet. We should probably do that in class. So let's now take this thing, and I've achieved my first 2 goals. My first one was to get a 1 here, and then zeros below it. Now I need to get a 1 right there without changing that first row. So everything I do now is just going to be working with the bottom rows. Actually, I notice if I just swap these 2 rows, I'm good to go. So I'm just going to swap row 2 with row 3. So I've got 1, 1, 1, 4. I've got 0. So this is the next row now. 1, -3, -1, and 0, -4, -1, -9. Okay. So now that's the third thing I wanted. So the 1 here, the 0's there, the 1 here. Now I need to get a 0 here. And I'm going to do it in a similar fashion to what I did above. above, before here, but now I'm going to be working with this one, clearing that out. I'm not going to touch that top row anymore. If I add that top row to anything, then it's going to, put stuff here, and I've got zeros there, and I want to change that. So at this stage now, I'm going to leave the top row alone. 1, 1, 1, 4. I'm going to leave the second row alone. That's a 1, isn't it? Let me try something here. That looks better. -1, and then I'm going to replace row 3 by row 3 plus 4 times row 2, right? Because the 0 plus 4 times 0 is still 0. The -4 plus 4 times 1 is 0. The -1 minus 12 is -13. And the -9 minus 4 is -13. Okay? So I got a 1 here, 0's under it. A 1 here, 0's under it. The next thing I'm looking for is a 1 right there. Well, I can't really use anything above, so I just got to use that for itself, and I'm just going to divide row 3 by -13. So what I end up with is 1, 1, 1, 4, 0, 1, -3, -1, 0, 0, 1, 1. Okay. Now, Gaussian elimination goes this far. It stops right here and says, okay, now what system do I have? I have the system x plus y plus z equals 4. I have y minus 3z equals -1. And I have z equals 1. Okay. So you've got that system. And then we do what's called back substituting. We know what z is, we can figure out what y is, right? So from here we say, well, plug this back into there, and you've got y equals, that's an arrow, plug this back into there, y equals -1 plus 3 times z. Well, z is equal to 1, so this is -1 plus 3, which is 2. Yes, it is. And then you take both of these and plug them back into here, because you can get that x is 4 minus y, but y is 2, minus z, whoops, minus z, but z is 1, right? So I'm just plugging in the known values there, substituting back into the ones up above, and we've got 4 minus 3 is 1. So I end up with x, y, z equals 1, 2, 1. Okay? That's what's called Gaussian elimination. You take your system, you make the augmented matrix, you do a sequence of row operations which puts you in row echelon form. That allows you to see one of the variables, and then you back substitute in to see what the other ones are equal to. Okay. Now, let's continue this into what's called Gauss-Jordan elimination. And what Jordan elimination does is it starts with this, it does all the reduction that Gaussian elimination does, getting us down to here. And then it says, I don't want to stop at row echelon form. I want to keep going to reduced row echelon form. So now we work, where to start with, we worked from the top down. We're now going to work from the bottom up. So my next goal is to get zeros above this bottom leading 1. So I need to get a 0 here and there. Well, that's not too hard to do, because I can replace row 2 by row 2 plus 3 times row 1. Not row 1. 3 times row 3. Right? The thing is, I'm going to multiply this by 3 and add it on. These zeros here are going to mean that I don't change that. So the bottom row stays the same, 0, 0, 1, 1. The next row, I've got 0 plus 3 times 0, 1 plus 3 times 0, -3 plus 3 times 1. Sorry. 1 plus 3 times 0 is still 1. And then this is a 0. And then I've got -1 plus 3 times 1. Negative 1 plus 3 times 1. Negative 1 plus 3 times 1 is a 2. It's so easy to make a mistake and then have everything wrong. So anyway, there's that. I also want to get a 0 right here. So I'm going to do row 1 minus row 3. I'm using this 1 to get zeros above it, right? So this one minus that one. This one minus that one. This one minus that one. Let's try that again. This one minus that one is a 1. This one minus that one is a 0. This one minus that one is 3. Good. So this leading one now has zeros both below and above it. Of course, there's nothing below it, so that's good. Now I move up to here and say, well, I've got zeros below this. I've got to get zeros above it. So I can use this to say, so the bottom 2 rows will stay the same at this point. 0, 1, 0, 2, 0, 0, 1, 1. And now I'm going to replace row 1 by row 1. In this case, the 1 and the 1 will cancel out if I just subtract off row 2 here. Okay. Again, the 0 subtracting off leaves that alone. The 1 and the 1 subtract to be 0. The 0 and the 0 subtract to be 0. And the 3 and the 2 subtract to be 1. And I'm left with that, which now looks like the following system. It looks like x equals 1, y equals 2, and z equals 1. That's Gauss-Jordan elimination. It gets you right down to the solution if there is only one solution. In the next video, we'll take a look at some things of what happens when there's either no solutions or when there's more than one solution. To recap, Gaussian elimination is get your augmented matrix, do some row operations to get down to row echelon form, reinterpret that as a system, and then solve the system by back substitution. You have one of the variables, you can get the others by plugging it in. Gauss-Jordan says go here and then continue on to reduced row echelon form, and then the answer should just be sitting there looking at you. Okay. One of the things we'll also do in class is to point out that your calculator can do this very quickly.